So let's also talk about some other common terms that you're going to need to know. So first of all, some components of networks are hosts. So the term, when it comes to networking, the term host is the device at the edge of the network that's creating the data. For example, your laptop, your PC, your tablet, your smartphone, your server. These are devices that are either creating the data because you're typing something in on the keyboard or because you're clicking on things, or the devices at the far end of the network that are receiving the data. For example, when you bring up your internet browser and you type ine.com and then you hit enter, well, your laptop is a host. It's now creating some data saying, give me the ine.com website. Well, guess what happens to that data? It goes to a server, another box sitting somewhere that's probably hundreds or thousands of miles away from where you are, and that device is also a host. That device receives your request and then gives you back the web page. So the two things at the end of the network, the thing that's asking for data and the thing that's providing it, those are called your hosts. Now, everything else in the middle that's facilitating that transmission, that's allowing the data to get from point A to point B, we call that the network infrastructure. And the network infrastructure is divided into several classes of devices. You have network access devices, such as hubs, switches, and access points. So when someone says, oh, well, what network access device are you connecting to? What they're asking you is, what is the very first network device that your laptop, smartphone, or PC is connecting you to, that you're connected to? What is providing you access to the network? So for example, if you're at home and you're using wireless, you've got some sort of little box sitting on your desk or something that they call a Wi-Fi access point or a Wi-Fi router. That is an access device. That is your very first entry point into the network. If that device didn't exist, you would have no way of connecting to the network. And then we have network infrastructure devices. These are devices that typically do not connect to hosts. Not always, but typically. For example, when most people think of a router, they think that, well, my laptop or PC is connected to a Wi-Fi access point, or maybe it's connected to a little switch or a hub, and then next is a router. Now, you could be physically connected to a router if you're in a home environment. If you're sitting at home or in your small office, maybe your laptop or PC is actually directly physically connected via a cable to a router. But in most companies, the router or the firewall is not connected to the host. It facilitates the transmission in the middle. That's what carries the information from point A to point B, but it's not at the access layer. It's not connected directly to the host themselves. Now, other than connecting via Wi-Fi, which we're not going to spend a lot of time talking about because the CCNA routing and switching doesn't really spend any time on Wi-Fi, any significant time. So 99% of what we're going to talk about in these videos is going to be dealing with wired networking, where the host device is actually physically connected to a cable that then gives you access to your network access device. So let's talk real quickly about some different cable types you need to be aware of. So in a local area network, you need to be familiar with that term, a LAN, a local area network. So a local area network gives you an idea of like the size of the network. A local area network is usually when, first of all, that's what your laptop or PC or tablet is connected to. Wherever you go, whether you go to Starbucks or the library or at home or in your office, what you are connecting to is called a local area network. That is the very first network you're connected to. Now, depending on the size and scope of that network will determine if that entire network end to end is a LAN or something else. A local area network is usually something where it's assumed that any 2 points on that network are maybe a maximum of, a few hundred feet away from each other, right? So if you think about your typical enterprise company, think about your company that sits in like an 8-story building, okay? So the LAN would be that network in that 8-story building. From the top floor down to the bottom floor, we might be talking about 200 or 300 feet from end to end, something like that. But a LAN is not the type of network you use to get miles and miles and miles to the server that's in the next state or in the next country. A local area network is not meant for that. So local area networks operate on some rules and protocols that assume that the devices that are trying to connect to each other are pretty close in proximity, that you could walk from one device to the other without having to get in your car and go anywhere. So on LANs, the type of cables we have can fall into 2 general categories. Most LAN cabling falls in the category of copper cabling. So with copper cabling, you have coaxial cable, which looks like this. So if you use cable modems at home, your cable coming out of your wall looks like this, and this is called a coaxial cable. It's got that little spiky, pointy thing sticking out of the end of it there. So that's coaxial cable, typically used for cable modems or cable TV. And then you've got twisted pair cable. And twisted pair cable, on the end of it, typically has a connector that we call an RJ45 connector. So this type of connector that we see right here is called RJ45. And there's actually multiple wires inside here. And if you actually look real closely at your RJ45 connector, you'll see different wires of different colors like red or blue or brown and white. And then all those wires are twisted together in pairs. So every 2 wires are twisted into a pair. And that's why they call this twisted pair cable. So in your typical Ethernet cable, you will have a total of 8 wires. And those will be twisted into 4 different pairs. So there will be 4 pairs of wires, a total of 8 individual wires twisted together, and then it's encompassed by this plastic or rubber sheath or coating on the outside. Now, twisted pair cabling comes in 2 general types. Most people, when they're doing Ethernet cabling and setting up Ethernet cabling in their work, will use what's called unshielded twisted pair. Sometimes they'll be called UTP, unshielded twisted pair. The opposite is shielded, so it's probably easier for me to talk about shielded first and then explain unshielded. So remember, in this copper cabling, what's really going on? It's taking the electrical signaling from your laptop or your PC, because everything in your laptop or PC is done via electricity, right? If you're not plugged in, if you're not turned on, nothing's happening. So once you plug in and turn on your laptop, everything you do, every key that you press on your keyboard, every click that you do on your mouse is generating some kind of an electrical signal in your laptop. And when we're talking about networking, we're talking about transmitting those electrical signals across a wire so they can end up on some other host somewhere that understands those exact same electrical signals. So these type of copper cables here, the copper, whether it be in your coaxial cable or in your twisted pair, is carrying electrical signals. It's carrying electricity. Probably don't want to put that up to your tongue unless you have a death wish. So in a shielded twisted pair cable, what that's for is the electrical signal going through these cables, as it was going through the cable, if that cable was close to something that generated a lot of electrical signal, for example, maybe a big electrical generator, okay? So let's say we're talking about a big industrial plant that has big, massive machines that generate a lot of electrical energy and have a lot of electrical signal. Well, as the electrical signal in your cable is going past one of those things, there's a possibility that this massive electrical signal coming out of this big generator, like a dam or something, could actually interfere with the electrical signal in your cable. And so what that could result is when that electrical signal pops out of the other side of the cable, it might not look like it did when it started. In other words, it's been corrupted. The signal that you put on the cable at the very beginning now no longer looks like the signal at the end. Now, this doesn't happen very often. Most cables these days are produced in such a way that that isn't very common. But if you're in a large industrial complex, something like this with big generators, and you think that might be a problem, that's when you would probably want to purchase shielded twisted pair, which means that the electrical signal inside that cable is shielded from outside electrical interference. How is it shielded? Well, if you actually open up that cable, you would see that just underneath that plastic coating, usually there's like some aluminum foil. It's like aluminum wrapping around the actual wires themselves to provide additional protection against electrical interference, whereas unshielded twisted pair does not have that aluminum foil coating on the inside of the cable. Now, as you can imagine, shielded twisted pair is significantly more expensive because it's harder to make than unshielded twisted pair. But for 95% of cable deployments out there, for Ethernet deployments, they don't really need the extra expense of the shielded twisted pair. Unshielded twisted pair is just fine for vast majority of stuff. Now, we said that a local area network assumes that two devices are within walking distance of each other. The opposite end of that spectrum is what's called a wide area network, where the two hosts are hundreds or possibly thousands of miles from each other. For example, if I'm here in the United States and I bring up a website that originates in England, well, clearly the network that's being used to carry my data to that server in England is not a local area network. That is a huge network, and that's called a wide area network. So wide area networks use totally different standards. The type of electrical energy that's used to get data from my laptop to another device that's 10 feet away doesn't need to have that much electrical strength, whereas the electrical energy used to push my signal 3,000 miles to England or Spain or Greece, that's a whole different story. So wide area networks, because they use different kinds of electrical energy and because they represent information differently as it's going across the wire, they have to use different kinds of wires. So a lot of times the wires that you'll see in a wide area network, or I should say that connects to a wide area network, are serial cables. Now, before I show you some examples of serial cables, look back up at your LAN cables there for just a second. Your coaxial cable will always have an end or a connector that looks like what you see here, with the little pointy thing sticking out of it. Your Ethernet cable will always have an RJ45 jack on the end of it, most likely. If it's a copper Ethernet cable, it'll look like that. Now, if I say, give me an example of a serial cable, I want you to connect your device to a WAN, you need a serial cable to do that. Well, serial cables come in various different flavors. For example, DB9, or as you can see here on this picture, let me make this a little bit bigger. You can see there in the right corner, EIA TIA 232 or V.35 or X.21. Now, what does all this mean? These are all different connectors for serial cables. And you can see from the picture here, how do they vary? Well, they vary in their size and their shape and how many pins they have. Now, at the CCNA and even really up to the CCIE level, no one's going to expect you to know what's the real difference between a V.35 or a DB9 cable. No one's going to expect you to know how many pins there are, or that pin number 1 carries transmission signals, whereas pin number 12 carries receive signals. No one's going to expect you to know that. But what you should take away from this is that number 1, there's lots of different kinds of WAN cables. So if you're in the business of cabling or inspecting cabling, you're going to need to be able to differentiate these different types of WAN cables. Secondly, the type of connector that you select, whether it be DB9 or V.35, really depends on what am I connecting to. Usually the device that I buy, the box that I buy that connects me to the WAN, that box will have some kind of a connector. If I purchase a box that has an X.21 connector, well then clearly I got to buy an X.21 cable that's got an X.21 connector to that. So really you should just be able to recognize these. You might get a multiple choice question on your ICND1 exam that says, okay, of these various types, select which cable type is a WAN cable. And it might say RJ45, V.35, and DB9. And you'd be expected to recognize that, okay, RJ45, that's typically a LAN cable, so the correct answer would be V.35 and DB9. So they'll just expect you to recognize that as being WAN cable types. Now, all of these cables I've shown you here are copper cables. In one form or another, they've got copper cabling, which is carrying your electrical signaling. Another type of cabling that you might see is what's called fiber optic cables. So fiber optic cables, in order to transmit your data, instead of using electrical energy, actually use light. They use light energy. And That light can be either really strong, like from a laser. If we're trying to send fiber optic very, very far, it uses laser light. Or if it's a shorter distance, it could use LEDs, light emitting diodes, which is a much weaker source of light. So your fiber optic cabling, you should be familiar with some of these terms. So first of all, before I go into MMF and SMF, look over here on the right. These are the types of connectors that typically would connect to a fiber optic cabling. So GBIC stands for a gigabit interface connector, a gigabit interface connector. So if you ever buy a router or a switch and it says, okay, it requires GBICs, then this is what a GBIC would look like. And if you see the term GBIC, normally that should say, aha, a GBIC usually connects to a fiber optic cable. It's using light to transmit data. Now, GBICs were sort of the first ones that came out. Then later on, we had SFPs, which stands for Small Form Factor Pluggable. Once again, an SFP also connects to a fiber optic cable, but they're smaller than a GBIC. You know, in a router or a switch, you can fit more of these into the same space where you would fit less GBICs. So these are the two different types of connectors you typically find for fiber optic cable. Now, what do these terms mean right here? So we've already talked about GBIC and SFP. The top ones here, MMF, that stands for multi-mode fiber. Multi-mode fiber. And SMF stands for single mode fiber. Now, these are different types of fiber cabling. Multi-mode fiber is typically the type of cabling that you would use when you don't need your fiber optic cable to go very far. For example, let's say I had a building that had 10 stories, first floor up to the 10th floor, and I decided that I wanted to run fiber optic cabling in my building to connect each of the floors together. And one reason for this is fiber optic cabling can transmit data a lot faster than copper cabling can. So when we're using electrical energy to transmit our information from point A to point B, you're limited to certain speeds. It can still go pretty fast. But if you're talking about light, like laser light, well, light inherently goes a lot faster than electricity. So you can transmit your data much, much faster if you're using fiber optic cabling. The downside is it's typically more expensive and it's more difficult to install. But let's take that example of a company that has a 10-story building and they want to run fiber optic cabling. Well, that's not very long. In other words, the cables used to run through that building, although it might seem long, we're not talking about miles of cables here. So in that particular case, we would probably use multi-mode fiber cable. As opposed to, if I was going to have a fiber optic cable connecting my company, my building, to a service provider that was 10 miles away. Well, multi-mode fiber doesn't really operate that long. It can't push the laser light or the LED light far enough to where something 10 miles away would actually be able to pick it up at the other end. That's where we'd have to use single mode fiber. So single mode fiber can actually carry data about 50 times, that's 50 times further than multi-mode fiber. So a lot of times people will say, well, if the fiber cable you need needs to go a distance of 5 miles or more, probably a better idea to use single mode fiber. Now let's take this back once again from the IC&D 1 perspective. How might they test you on this? They would expect you to recognize that GBICs and SFPs are your typical connectors that connect to fiber optic cables. So you'd have to know that. You should also know that multi-mode fiber and single mode fiber are two examples of fiber cable types. So if someone says, oh, I want you to go out and buy some fiber optic cabling, one thing you'll have to ask them is, do you want multi-mode fiber or single mode fiber? So, and the IC&D 1 will expect you to know that. And then the last thing is, the IC&D 1 will expect you to know that single mode fiber is what you use when you need really long distances of fiber optic cabling. Whereas when you need just shorter distances, multi-mode fiber is typically more than sufficient.